In this lesson, we're going to be going over image acquisition under Linux systems. When we acquire an image, what we are looking to do is we're looking to either acquire an entire hard drive, so all of the data on a hard drive, or we're looking to maybe just get one partition. Under Linux, we've got an advantage of having a built-in tool that will allow us to do that image capture. And that built-in tool is actually called DD. So I'm going to use DD here in order to capture data from a USB stick that's plugged into the system that I'm on. Now, what DD is doing is it's getting a bit-for-bit image of this USB stick. So for every bit that's on there, we're going to be writing out that bit to this file here that I'm calling stick.dd. Now, the output of DD is actually what we would consider a raw format because we haven't done anything to it. It's not in any other form other than exactly the way that it was stored on the hard drive. Now, what I'm doing is I'm actually capturing the partition. So I'm capturing the one partition that's on here. I'm not capturing the whole drive itself. So I'm getting one partition's worth of data. DD is going to get this bit-for-bit copy. The downside to this is once I'm done, I'm actually going to have to go generate a hash of the data so that I've got some way of verifying that the data that I got is actually what was on the original source. Now, this is going to take quite a while, so let me show you an additional tool. You can see we copied 2.7 gigabytes there. I could actually take a look at this, and it says it's an ext3 file system, and it needs journal recovery, interestingly enough. So you can see that we actually captured the data that was there. Another tool that you can get is DCFL-DD. I'm actually going to generate the help on this so you can see what we can do here. I can get the hash and I could copy the bit-for-bit data just like DD does, but I could also get a hash of the value. And that's actually what I'm going to do here. I'm going to do DCFL-DD input file. It works much the same way that DD does. So that's going to be /dev/sdb. In this case, I'm going to get the whole drive. Output file equals whole stick.dd and hash equals md5 and hash file equals stick.md5 and hash log. And I need administrative privileges to do that, so I forgot I have to do sudo there. So I'm going to do sudo, and you can actually see that it's outputting the number of blocks and the size of the file that has been written here. So I'm doing the bit-for-bit copy just like DD does, and when I get all of the data written out, I am going to generate the MD5 hash of that value, and I'm going to place that MD5 hash in this file called stick.md5. Now, there are additional tools that you can get that will do these image captures. There's one, for example, called Cyclone, and it's a bit more of a user interface-driven way of doing this capture, but the tools DD and DCFL-DD work really well. As I said, DD comes with Linux just built in. It's always there. And yeah, you have to go do the MD5 or the SHA-1 hash in addition to just capturing the data using DD, but it doesn't take that much more effort in order to do that. Now we're done actually capturing the data, and you can see that we had 244,736 blocks written out. And you can see that the in records match the out records. So we didn't have any problems with capturing data and being able to write it exactly the same way. So now I should be able to cat stick.md5, and now I've got the MD5 hash value from this file that we created of the whole stick.dd. Now if I do a file on wholestick.dd, I should get some sort of master boot record indication. So, yep, I've got the boot sector there. You can see all of the data around what that boot record looks like, or that boot sector looks like. We've got 8 sectors per cluster and 2,238 reserved sectors. You can see it looks like there's 255 heads, although that's not really accurate because, again, this is a USB stick. It doesn't actually have heads, or at least not heads in the way of spinning platters have heads. So while there are other tools that are available under Linux to be able to capture data, DD and DCFL-DD work pretty well. And as we've gone over here, DCFL-DD is really just DD with some additional capabilities specifically around use for forensic purposes. So again, I can create the MD5 or SHA-1 hash just as part of the whole process of capturing the image.